Today we're looking at section 8.2, applying exponent properties involving quotients. What happens when you divide a to the fifth and a to the third? Well, we can expand a to the fifth, and you'll see that it's 5 factors of a being multiplied. And when we expand a to the third, it's 3 factors of a being multiplied. And we know anytime a is over a, we get 1. So all of these are canceled out. 3 on the top and 3 on the bottom because they pair up to give you 1. And when you multiply it, it's 1 times 1 times 1 times a gives you a squared over 1, which is a squared. Now notice, if we had simply subtracted the 2, we would have gotten the same answer. The exponent 5 minus 3 is a squared. This leads us to the quotient of powers property that simply says when you have the same base in the numerator and the denominator, to divide you simply subtract the exponents. Here's an example. 4 to the 7th divided by 4 squared equals 4 to the 7 minus 2, which is equal to 4 to the 5th. So you see we subtract the exponents. Now I want you to pause this video and I want you to try these 4 problems on your own. Remember, subtract the exponents. To do this also, you have to remember they have to have the same base. Be careful. Here's the answer to the first one. 10 minus 4 gives you 6. Number 2, again, we just subtract the exponents and get x to the 4th. Here on number 3, you have to be careful because you have x's and you have a y. So handle the x's by subtracting. That gives you x to the 3 minus 2, which is x to the first, or x. And then you have just the y by itself, giving you xy. Number 4, you have to multiply first, then subtract your exponents. Give that a try. Is this what you got? Remember, you have to subtract the exponents, and then when you have a smaller number like this, go ahead and multiply it out. 4 times 4 times 4 is 64. Now we have the power of a quotient property, and that says to find a power of a quotient, that's 2 things being divided. Find the power of the numerator and the denominator, and then divide it. So you can see from this example that the m gets applied to the a, the m gets applied to the b. So a over b to the m power is equal a to the m, b to the m. Well, here's an example. 3 squared to the 7th power. That equals 3 to the 7th over 2 to the 7th. Now I want you to try these on your own. Remember that the exponent goes to the numerator and it goes to the denominator. Pause the recording and see what you can do. So here I went ahead and I applied the 2 to the 5 and to the 6, and I got 5 squared over 6 squared, 25 over 36. On number 2, same thing, negative 8 over 27. Look at number 4. Did anybody go 1 to the 3rd equals 3? Remember, 1 to the 3rd is 1 times 1 times 1. Now let's put it all together. When you have 2 bases, numbers being divided, and you have the same base, you subtract the exponents. When you have 2 numbers being divided, being raised to a power, you apply the exponent to the numerator and to the denominator. Now here's kind of a tricky problem where you have both properties being used. Remember to give the exponent to everything inside the parentheses. So 4 to the 3rd, x to the 6th, 3 to the 5th, y to the 3rd. Remember, this is the power of power properties. An exponent raised to a power, you multiply. When we solve all that, 4 to the 3rd is 4 times 4 times 4, which is 64. X to the 6th. 5 to the 3rd is 5 times 5, which is 25 times 5, which is 125, y to the 3rd. Have a great day.